Hey, I think this is recording. I sure hope it is. And this would be the lecture well, for the Monday, Wednesday class. This is like the lecture you lost when Zoom was crashed. The first day, of course, is on the 24th. So this is like a supplemental lecture for Monday, Wednesday people. For Tuesday, Thursday, this is the Tuesday lecture for this current week, which I believe is the last day of August. Yeah, actually, first day of September. So for the Tuesday, Thursday crowd, this is the September 1 lecture. We'll try to do almost, but not quite half of the lectures. I've got a tentative schedule recorded. More than half of them will be live. We'll try to do mostly Monday, Tuesday recorded, Wednesday, Thursday will be live, but that will change slightly as we run into holidays and other issues. Monday, Wednesday lost a class, loses another class because of an extra holiday. So I'm afraid for you guys, you're going to have a makeup lecture right around Labor Day as well. Sorry about that, but two of my sections are steaming ahead, and the Monday, Wednesday is lagging behind, so we just have to slip them in. That's the advantage of recorded lectures, at least as far as I'm concerned, maybe not as far as you're concerned. Well, let's take a look at about 3 sections out of Chapter 2. Hopefully these will go fairly lightly. And as you can see, some of you have already visited this page as of Sunday evening, Sunday late afternoon when I'm recording this. So starting with a bunch of numbers is what we're going to have here, a little bit of R work and stuff. Variation refers to a particular kind of variation. Variation in data doesn't start out as data. I don't want to read this whole thing to you, but no people look exactly alike. No two trees look exactly alike. We do want to find what type of variation there is, but there are a few groups. You don't see this in the real world very often, but look at that group. No variation at all. It's all twos. It's like if everybody in a particular class are exactly the same age, there will be no variation, at least to the nearest year in their ages. There wouldn't be any use to use statistics, wouldn't be any need. There wouldn't be any variation. 9 twos. But now here's another group. There's not a ton of variation here, but it does have some variation. And it's not quite as easy to describe them. You might want to put them in order and various other things could be done. But trying to find patterns in numbers would be a nice thing to do. So what we can do here is to take a look at my vector 1 and my vector 2 and see what happens. And they apparently have done that for my vector 1, which is the 9 twos. So they've already put that in there. Now we can create a vector called my vector 2 with these numbers, and I suppose you could copy them or just type them in. I guess I will type them in. 2, 1, 3, 3, 2, 3, 1, 2, 1. Okay. Now I guess that's all I need to do. Let's go ahead and run them. Let's just see what happens if you run it now. And let's see what the hint might provide us. Use the C function, okay, to convert to a single vector. So I'm going to hit run. The thing is, I've not specified what it is I want to have printed, so I'd better put their names down. And let's do that over here and see what happens when I hit run now. There they are. Now notice there are no commas, there's no parentheses, there are spaces between the numbers. So these numbers are small, so there really isn't any problem with that. So you see the first one is my vector 1 up here, all twos, and the second one, my vector 2, has the other numbers there. It did have some variety. Now we can take the numbers in my vector 2 and sort them in ascending order, which is the default, from low to high. And you can use the sort function for that. And in the same box, let's go ahead and continue with this, and I'll just copy it, I guess. Let's see, copy, however you do it. Mine's Command C, and then over here, Command V. And I'll just run the whole thing again. And so the first 2 lines were the same, but this last line here is sorted. 1, 1, 1, 2, 2, 2, 3, 3, 3. It's all sorted, ready to go. It's easier to see a pattern now when it's put in order. And so sometimes data is put in order by default, but here we have to do that, and it will go from low to high, ascending order by default. You can go the other direction if you want. We'll talk about that in a little while. But we can also do tally, and tally will actually give us a way of seeing how many ones, how many twos, how many threes, etc. And later on, we'll tally people's ages and see what happens with that. But with the tally command, we get 3 ones, 3 twos, and 3 threes. It's a little unclear, but the top line here does have the types of numbers. We have the ones, the twos, the threes, and this last line has the tally, the number of the ones, the number of the twos, the number of the threes. Let's see if I can slip that in here, and let's see if I can just slip that in this R window. Could just done this in a sandbox, I suppose. The tally, and I'll type in my vector 2, and just run the whole thing, and they'll just give me a bunch of duplicated lines, but there it is at the bottom. As you see, they hinted that they would have the X's and then the 1, 2s, and 3s. Let's close this up, and then you can see the last line where you have 3 1s, 3 2s, 3 3s, as they predicted. But now we can see that we did it ourselves in the R box, specifically the R console, the output. I'll let you look at these little quizzes later. But then there's also comments, and the way I understand it is I can look at your comments, whether I will do so on a regular basis. It just depends on how much time I have. I may or may not have a lot of time for that, but I'll probably spot check to make sure you're doing it. In other words, if you tried this tally on my vector 1, you should have just the ones and then 9 of them. So it'll just be a single category, the ones, and there'll be 9 of them. So I'll let you experiment with that if you like. So let's see, let's try it. In fact, well, speaking of which, let's do it right here. We'll type in tally and then my vector 1. And make sure it's closed up, and we'll just run it. And my vector 1, by the way, was all 9s. So all we had were, that is all 2s. There were 9 of the 2s. So this tells you what the numbers are and how many there are that follow. So it's a little bit unclear unless you see the pattern. So we have the 2s, and there are 9 of them. If you did the same thing, let's just change this over to my vector 2, and we've already done that. So let's just go ahead and double check it. Oh, we didn't have that before. So yeah, that's an error. So here, my vector 1 was already done. So that's a mistake. So believe it or not, we've learned a second statistical technique, frequency tables, implemented as the tally function. And as we learn more and more about statistics, we'll encounter a lot more techniques like this. So that's a short beginning section 2.0. Let's move over to the others, and let's try at least a couple more. I think I'll just have time for a couple more. From numbers to data, and here we have data, which is just the numbers that we're going to be trying to analyze. It represents something about the world. And two people of the exact same height may be different from each other in almost every other way, but they may be the same height. They may be 5'9" or whatever the height might be. And you can still attach a number of them representing their height, typically in terms of inches or in terms of centimeters, because you get feet and inches, it gets to be a little bit messy. And I'm not going to read all of this to you. You can kind of, read this yourself. And can't study all people, but you want to represent people by the data you happen to be analyzing, whatever it may be. Age, height, and weight seem to be from standard ones. But they ask us a few things about some certain cases that you can certainly check out. And sometimes we find the data are collected for no particular purpose or for someone else's purpose. So you may think of a question after the fact that we can answer with the data. So sometimes it comes along afterwards. It's called experimental data. Sometimes they're just forging ahead to see what might be out there. You don't really have an agenda. So here's an interesting one. Two different researchers collect the same measures for different purposes, a hospital and a dating website. So you've got a hospital, dating website, both interested in collecting data on heights and weights. And why might a hospital collect this data? Well, they may want to know how their patients are doing. They want to know what the height and weight are, the people who are there, and perhaps especially the weight, especially if they're obese or something like that. The dating website might be collecting it just to list as a fact for people to see what's interesting to them. And then they summarize it, of course, so you can then read what their thoughts were on the issue. And yeah, when you have changes in weight, especially going up, might show an improving or worsening condition, and then they might want to decide whether to interact with another person based on if they're too tall or too short or too heavy or whatever. So a hospital can go about actually doing the physical measurement. This is an easy one. They would simply do that. But a dating website would probably rely on people's typing in whatever they say, and hopefully honesty is a part of this, but it might not be, whereas the hospital would be as honest as possible. So what might be included in the hospital sample, who might be included in the dating website sample? Well, these people are rather different, as you can probably see at the bottom of the screen. Yeah, you've got all kinds of people in a hospital, but sometimes they tend to be older and sick, and these people are the ones that are in the hospital, whether it's COVID or anything else. Um, older people are more likely to be sick, but the dating website, as they're saying, might be younger and healthier. So yeah, there's completely different purposes for these. And think of a few interesting research questions that could be asked about this situation, and that could be something related to the disease they may have, whether they're obese or not. That one they don't really clarify. I'll let you just come up with something there that might work out. But the dating website, this might be a little bit more interesting, and that could be asked about the situation. And so, you can try stuff like that to see if people are more interested in an optimal weight or looking for thin people or looking for tall people or something like that. And as you collect the data and then you see responses or something like that, you might want to cue in on the perfect person for the dating website, whereas the hospital might be more interested in the average person or the average change in weight especially. I don't think they care about the height that much, and height really doesn't change. Let's take a look at organizing data in a data frame. So we'll get back to the numbers here. In statistics, we generally organize data into rows and columns, and here's a small example of a set of data organized this way. So we have condition is either uninformed about a certain thing or informed about a certain thing. And we have the age, we have the weight, and we have a different version of weight. So let's see what this might be. These are housekeepers. Let me see if I can expand the screen a little bit. Yeah, a little bit. That's easier to read if I can try to do that. So 6 different hotels, and there are 6 rows, so 6 housekeepers are in this data set. Depending on the study, rows could be people, etc., states, whatever. But the columns represent variables. Here's a variable, here's a variable, here's a variable, and here's a very similar but not quite the same variable. So condition, and you're saying that the daily work, I'm sorry about the phone, I should have unplugged it. The housekeepers were either informed or not that their daily work of cleaning hotel rooms is equivalent to getting adequate exercise for good health. So that's a hidden benefit in certain jobs, that you're staying healthy as you do your job. Not every job has that, but this is one of those that does. So sometimes they were told of that, and sometimes they were not told of that. So we have other variables such as the housekeeper's age, the weight before they started the survey, and the weight, and then the weight at the end of the study. And this one has a little bit more accuracy as well. You've got typically these have changed just a little bit. This person lost a lot of weight, and this is also measured to the nearest tenth of a pound, and this was not measured to the nearest tenth of a pound. So that would be a difference there. So anyway, you can see the 4 variables. These numbers are simply just the numbers of the housekeepers, number 1 through number 6. And so anyway, we've got a little question you can ask with these. You don't really worry about the scores on these. You just want to try to learn something here. We're not judging you on that. The quiz is what we'd like to judge you on. I'm still working out the details on that. But does this mean that there's 6 variables for age? And by the way, values and variables are completely different. Values are just simply the numbers, like 45 is a value. But the variable is weight number 2, that kind of thing. So value is not quite as important as a variable. Variables are made up of many values for sure. And so we have 6 variables for age? No, we have 6 people. So that's no. Not many people responded to this yet, but those of you who have gotten ahead, fantastic. You're ahead of me. So age is a single variable, and there are 6 values of age for the 6 housekeepers. So you see they range between 29 and 52. And how many variables are shown? 4 variables, of course, yes. So there are 4 variables, which they pretty much tell you some of the answers right afterwards, but not always. So the numbers 1 through 6, these are the numbers, the housekeepers. From housekeeper number 1 to housekeeper number 6, they don't have their names. They're just put in some sort of numerical order, maybe by employee number or something, who knows. But anyway, this is another shorter section. First column of numbers has no variable label, and we just numbers the rows, and that's it. These are called data frames. They include the rows and columns with the data. They also include some other information. It could be called metadata. So the names of the variables, like a header at the top of each column and a number, those headers do not count. Yeah, so they're just like explanatory situations. Let's go over to 2.2 and take a look at it. And this will be a data frame example called Mindset Matters. Okay, so here we have data that we've looked at the previous page. It's selected from a data frame called Mindset Matters. And we have 75 female housekeepers. So to keep it consistent by gender, they did not include any male housekeepers, just females. So anyway, data frame is a kind of object in R, and with any object, you can just type the name of it, see the whole thing. So we could try typing that in. So I think I'll take the shortcut and just copy it. Oh, let me slip down there. There we go. And I'll just go down here, go to another line, and just copy it there and run it. And so here we see that we have a whole bunch of variables, lots of them, at least 10 or 12, and don't even know what a lot of these are. I guess before and after, 2 is probably after the study was taken, and see if they went up or down. And then a wraparound with the informed and uninformed. Uninformed, once again, means that they were not told that exercise from their job will help them, and the others were. I guess they're interested in sorting through them. So roughly half are uninformed, roughly half are informed, just to see if there's any major difference. Maybe the informed people go to work even more happy and try to work out a little bit more as they do their job more exuberantly, try to lose more weight or something. I really don't know what the point was of that. But sometimes it's like a placebo in a control group or something along those lines. So we can see the whole output there, which I did. And you can definitely check this out. Of course, you'll be doing this yourself. I'm just trying to give you some pointers as time allows. We won't be able to have time to do them all, but we'll try to do at least several of them for you. It's a lot to take in, and so we have to kind of figure out how to speed things up, streamline things. So we have this head command that gives us the top 6. So we can simply, because they've already typed it in for us, see what happens when we run the command head mindset matters. And this should give us the first 6 rows as they're announcing. So run. Remember, you should always submit. I'm not submitting because I'm the instructor. I could, but we just don't have the time for that. So as I run it, then it took a little while to think about it. Let's go back to the beginning. It still gives us all these commands that have to wrap around. My screen is a little bit not, well, it isn't huge. I might be doing this on an iPad, and that'll make it even more condensed, but I'm trying to avoid that. I'm trying to keep the laptop going. So it has all those numbers, and then it has the first 6 apparently were uninformed. So they must have sorted it by that category or something like that. And once again, in case you missed it, they have replayed it here for you. Don't count on that happening every time. They don't always do this. Sometimes yes, sometimes no. I like it when they do because it gives you something to aim for. And then we can talk about what all these mean later. The body mass index, that one didn't change. This one went down. This one went up slightly. Seems like many of them are staying about the same. And some of them are just not available, which means I guess they're just not part of the data if they're doing averages. So the head command just simply prints out the first 6 rows of the data. Depending on your browser, output might not look exactly like one picture below as above. So as we mentioned, sometimes it just isn't going to print out that way. It may wrap around a couple of times if you've got a smaller screen. So anyway, you can make certain adjustments. I'll let you try that if you'd like. Condition didn't fit on the screen, so they put that on a completely separate set of data, basically. So let's try to read the data for the first housekeeper. So as we kind of make sure we can see this, the very top of the screen, and maybe we can get the categories too. First person clearly was 43 years old, weighed 137 pounds. At the end of the survey, went to 137.4 pounds. BMI was 25.1, stayed the same. Now, uninformed condition, and they had not gone through everything, but fat, maybe that's, I don't know what that means exactly. WHR, I'm not sure what that is. I'm not sure what the rest of these must be blood pressure, systolic and diastolic, I think, blood pressure. So that was measured, apparently. And they're all uninformed. So anyway, sometimes it's more useful to take a look at an overview of what's in the data frame. And this str command shows us the overall structure of the data frame, including the number of observations, number of variables, etc. So let's see what happens when we run it. And of course, the hint will just say to run it, so I'm not going to worry about that. So we run it and see, give it a moment, and it'll show you something here. Okay, so Now, what it's done is it's broken it out by variables. So it's kind of going the other direction. Instead of by column, it's kind of going by rows, a little bit different view. And there are 75 observations of the 15 variables. And it's kind of like the head command, although it doesn't say with 6. It just goes to, I guess, the top 10. Count 10 zeros. It looks like I've got 10. So somehow they arbitrarily picked the first 10 out of the 75 observations, 15 variables, condition, age, et cetera, and this is the list of the 75 housekeepers, of which you can only see the first 10. So in some ways it's similar to the head command, just in a different direction. So as you can see, that kind of all comes along. And what they decided to do with condition is they've decided to let informed be number 1 and uninformed be number 2. So this is like a abbreviation for a verbal word type of deal. So I don't know if they explained that, but I'm trying to say that they decided to let number 1 be informed and number 2 be uninformed. So that way you don't have to see the word spelled out. They could have picked maybe I and U. That might have worked, but they decided to do 1 and 2 instead. So that has to be clearly defined. They did not actually talk about that. There's a dollar sign in front of each variable name. Okay, that's nice. It's often used to indicate, in fact, for here, it is simply used to indicate what follows as a variable name. If you want to specify the age variable, you would then write mindset matters, $age. So just run it together. It has its own way of categorizing. Well, anyway, let's try one of our statistical techniques, and we can do this with a tally command, and it'll only take age. So we don't care about the other 15 variables. I'll just take the age variable towards the top there. And we'll make a frequency table with the tally command. So let's see. They're going to take the Mindset Matters data set, and then they're going to take only the age out of it. And then you could do either way. And let's see. They're not going to let us do it. They're just going to show us what happens. Okay, fine. So we can do either one. And apparently they both work. This seems like this is a little faster to me, but it does have age listed, and then it has the data. It's all from the Mindset Matters. And so what we can see is we have one 19-year-old. Remember, here comes the age first, and then the number in that category, which is by age. 121-year-old, 122-year-old, and all the way up now to 4 24-year-olds. That's a very popular one. It looks like we have 6 29-year-olds. That's probably what they would call the mode. So that would be the most popular age is 29. But it's just all over the map. You only have one 30-year-old. It's just too spread out. We have a 65-year-old. And then somebody didn't list their age or didn't get registered. And so that's what is happening. You're simply looking at the number of people done by age. The rows that start with 19, 37, and 54 represent the ages of the housekeepers. So that's what they were, 19, 37, and 54. The numbers underneath, as we just said, the number of each age. There are 3 housekeepers who are 45. We didn't specify that, but there it is. They kind of go in pairs. Excuse me. So the distribution, that's up to you to decide. It's too spread out to really get much out of this. It's not really a bell shape that we might come along and see pretty soon. But yeah, it looks like it's fairly spread out. There aren't as many people past the 50s, though, just a handful of people. There are a lot of people in the 40s. Might have been more interesting to divide this up by decades, but they didn't choose to do that. It is kind of all spread out. I don't really see much of a pattern. 20, 30, 40-year-olds seem to be pretty consistent, and the 50-year-olds drop off. But there isn't much you could say about that. But try to put something down. Don't leave it blank. That will not count for you. Try using the tally function. Make a frequency table of housekeepers by condition. So let's see. The hint will say, I think, tally. And it'll probably say condition. And so let's see. Let's type this in. Also keeping an eye on what they mentioned before. They didn't get a chance to practice this, but tally tilde age. Let's see if I can get over here. Tally parentheses, and then tilde, which is the command they're not explaining, they're just simply using. Finally, the tilde, that's the way over in the far left, and age. Well, let's see. I'll just type in age and then data mines. I'll just copy this. That's what I'll do. I'll just copy this and see what happens. And okay, so got that, and we'll just go ahead and get that in over here, and I'll erase this part. Copy. Okay, there we go. So now just run and see what happens. And it looks like that's exactly what we got before. It's not lined up exactly the same way as before, but you can see that it is giving the same data. There's one 19-year-old. Oh, I see. Oh, we've got a problem here. Yeah, now we've got kind of a double spacing situation. So the 19 goes to 1, the 21 goes to 1, and then now the 34 goes to 2. So that's a little awkward, I have to admit. That's not very desirable in my opinion, but once you get a little practice, you can kind of see what's going on with that. So, yeah, so frequency table of housekeepers by condition. Now, what was the condition command? I'm trying to remember what that was. Okay, so let's change age for condition, and that'll be the only thing we have to do now. So I'll type in condition. It should give us a series of numbers. And of course, I'll just run that. And so we have informed versus uninformed. We've got to close this up. And yeah, so this just simply gives us a tally. They've not gotten the index numbers yet. It's just 41 informed people and 34 were uninformed that doing their job would contribute to good health. And they thought that was interesting to separate that out. And so they did. It wasn't quite 50-50, but it was pretty close to that. And so as you see, they're giving you what you should have gotten, and we did. That's a good thing. And so that, as we just said, obviously 41 informed and 34 uninformed. And what do you notice about them? Well, more informed than uninformed. You can figure out the percent if you'd like. You could put that down. I'll let you do that if you'd like. You could say it's close to 50-50. There are a lot of ways to answer this. Just be sure to answer it. And make sure it makes sense, because you might have to do this on a quiz. Okay, so let's focus on the two variables, mindset matters, data frame, the age, and years at the start of the study. And the weight, their weight in pounds at the start of the study. And so let's see, we might want to sort the whole data frame by age. We can't use a sort function, it only works with vectors. So if you want to do a whole data frame, we have to replace sort, which is just for numbers only, with arrange. They're very similar, but here we have a different format. That's what ours is all about. It seems like changing the format's important. So arrange, mindset matters, and age. And we sort on one variable. The order of the rows will change for every variable. Okay, good. So anyway, you can see how some people have answered this. And age is a variable, and it won't be sorted by age. Age is a variable. The printout of mindset matters won't stay arranged by age because we didn't save our work, and that's important. So yeah, that's actually the answer to that, by the way, and we didn't save our work. So only one person out of 4 got it right, but very few people have gotten this far, which is not surprising. And I do have a student view I can use, which I'll probably use more often. I'm using the instructor view right now. Okay, so let's see. We can assign it to a new object. Let's just kind of read this carefully. Print out a mindset matters, won't stay arranged by age. We didn't save our work. In order to save it, we need to assign it to our object, and we could call it something else like mindset 2, or just assign it to the existing object. But it will revise what's already in there, and it'll change out what used to be in there and replace it. I always go for the shortest variables as possible, but that's me. Use the assignment operator to assign it back to mindset matters. So let's see how we could do this. So we could then arrange, and I'll go ahead and use the less than sign, the hyphen, and then call that mindset matters. Mindset, and it's capital matters. And let's take a look at the hint, see if I'm on the right deal. So save it back to my mindset matters, and then print. So here we could type in head mindset matters. First 6 is always head, so I'll just go ahead and type mindset matters, and then let's just run it and see what happens. Okay, so let's see. It was okay, didn't like that. I did something wrong. I'm not sure what, but it does have all the variables, and it did print out just the first 6. That part is good, along with the uninformed part. So let's see what they got. And it looks like mine, except theirs is more range. They have a little bit more room on their laptop than I do. And so, yeah, it looks like it's the same age, 43. Okay, they've arranged it, though. I have not arranged it. That's the problem. So run, and let's submit. And it's not correct, so I'm going to go ahead and check the solution, save you a little time here. So what I didn't do was arrange Mindset Matters, comma, age. That's what I did wrong. So now I can submit that, and it should work. And it'll match now. It says good job. Well, you don't want to get in the habit of that, but I may have to do that from time to time when I get stuck. I don't want to waste your time. Really, it's difficult to pause these recordings. So there you go. I forgot to type in comma age, so that was my fault. Now you can see in big print what happened here. It got arranged from the youngest person, second youngest person, just the youngest 6 people. And if there's a tie, I'm not sure how they break the tie exactly, but maybe it's go in order from the list. And we could go in descending order from, say, oldest to youngest by using descending. So if we typed in that, we would have a different look at things. And just to zoom ahead, well, it looks like they haven't sorted it by age. They've sorted it by something else. Well, maybe they just didn't print it. So let's just see how we could do that. What we had done last time was to say arrange. So let's do the same thing. I'm just going to copy this and type it in, or type it into the Mindset Matters. Oops, gotta try again. So let's see. Got all that. Okay, so now Command C, and over here Command V. Okay, now I'm just going to run it and print out. Okay, well, I could type head, I guess, but let's just go ahead and return head. I guess I'll type Mindset Matters and see what happens here. And mistakes are how you learn, so I do intend to make some mistakes, whether they're on purpose or not on purpose. I'll let you figure that out. Okay, so it looks like we probably have it here, but now I did sort it by age, and somehow they didn't do that. I'm not sure why that happened. Is that a mistake or a glitch? I couldn't tell you. Maybe they sorted by weight. Okay, this looks like a glitch here. They decided to sort by weight because they got maybe the heaviest person here, and as I can see, it's getting shorter and shorter, and smaller and smaller and smaller. But I did it by age, so I think mine's correct, and theirs is incorrect. So we've got the oldest person here, and all the way to the 55, and then the other one that wraps around the condition that's uninformed and informed. Well, I thought about doing 2.3, but that'll have to wait. This being a fill-in lecture to miss the Monday, Wednesday class, and to supplement the Monday, Wednesday class, Monday, Wednesday will be back to 2.3 on Wednesday. So if you've missed this lecture, you need to fill it in because I'm afraid I'm going to have to stay up with the other 2 sections. I hate to do it. I will not do this all the time, but we do have a couple of instances where Monday, Wednesday just has to do a little makeup, and that's a hidden advantage for me to get you back up to speed because I can't keep you on separate tracks. And for you to be 2 classes behind just wouldn't work at all. So I have to make sure you're all kind of caught up. So Tuesday, Thursday crowd will be going a little bit slower to let the Monday, Wednesdays catch up because of the holiday on the Zoom. Turns out Veterans Day and Thanksgiving do cancel out, but Labor Day will be an issue for the Monday, Wednesday crowd. So Monday, Wednesday will be back to 2.4, and Thursday, 2.3, Thursday and Wednesday we'll start with 2.3. That will be a live lecture. So the usual pattern, but there'll be a lot of exceptions. It'll be taped on Monday, Tuesday, and live on Wednesday, Thursday, at least for now. But Monday, Wednesday has a little catching up to do. So they're live on Monday, live on Wednesday, and this insert for the Tuesday lecture, the missing lecture. If you've already done this material, you can just skim through the video. You can skim through the work. That's up to you, as long as you learn it and can do pretty well on the quiz, which should be a good indicator of success for your test. And same with the regular R work. If you find you're getting it most of the time, that's wonderful. If you're getting it all the time, wow, you could teach the class. But anyway, that seems to be all I have right now. I just have to figure out how to turn this thing off. So I will attempt to do that now. And have a nice day, and we'll talk to you soon. Talk to you live on Thursday and Thursday, actually Monday, Wednesday, Thursday, I'll be live. So you judge that as you see fit. So talk to you soon. Bye-bye.